Welcome to This Explainer. Today, we're diving into a massive AI breakthrough that cures a pretty major headache, which is figuring out how to give artificial intelligence a human-like memory. We're going to explore how we can finally teach AI to remember its own best ideas, allowing it to autonomously self-improve. Honestly, it's a fundamental shift in how machines learn and reason. To truly appreciate why this is such a game changer, I want you to imagine something for a second. Imagine you're taking the absolute toughest exam of your life. But every single time you sit down to answer a question, your memory of all your previous studying gets wiped completely clean. Like a goldfish cramming for finals, you have to start from absolute zero every single time. As frustrating as that sounds, well, this is the current reality for standard large language models. They just don't retain the memory of their past reasoning successes to help them with future problems. But what if they could?
To see how we actually fix this AI amnesia, our explainer today is going to cover the core memory problem, introducing memory of thought, its two-stage pre-thinking and recalling process, and finally, the hard performance data to see just how well it works.
Section 1. The AI memory problem and the cost of starting fresh. So traditionally, improving an AI's reasoning meant facing a massive bottleneck. You'd have to rely on highly annotated, meticulously labeled datasets and run incredibly computationally expensive fine-tuning just to update the model's actual parameters. It costs a lot of time, and yeah, it costs a ton of money. But the alternative introduced by the memory of thought, or MoT framework, it bypasses this entirely. By using unlabeled data and an external memory system, the AI literally gets smarter without needing those wildly expensive parameter updates.
All right, Section 2. Let's meet memory of thought and see how it mimics human cognition.
So, back in May 2023, researchers at Fudan University published Memory of Thought, or MoT for short. It's a novel framework that essentially equips large language models with an external memory system. It gives them the ability to pre-think, store, and then recall past reasoning paths. Basically, it means the AI doesn't have to start from scratch every single time it encounters a complex problem.
The core philosophy behind the research is actually pretty simple. MoT mimics human cognition by allowing the LLM to think, store, and recall. I mean, think about your own life. When you calculate a tip at a restaurant, you aren't reinventing the entire concept of percentages from scratch, right? You remember past decisions and mental shortcuts to make better, faster future ones. MoT allows the AI to do exactly this. It stops relying on random, hard-coded examples and instead focuses on high-quality, relevant memories from its own past reasoning.
Moving on to Section 3. Stage 1. Pre-thinking. This is basically taking the practice exam.
So how does the AI actually build these memories without any human intervention? Well, it happens in two steps during this pre-thinking stage. First, the AI is given an unlabeled dataset, meaning absolutely no one has told it what the correct answers are. The AI just generates multiple different reasoning paths for these questions. Then, in step 2, it uses a majority vote system. It looks at all the different ways it tried to solve the problem, finds the most consistent, frequent answer, and essentially says, aha, this reasoning path is the most reliable. It then saves that specific, high-confidence thought into its external memory bank. It is exactly like taking a practice test and learning the underlying logic before the final exam.
Which brings us to Section 4, Stage 2, Recalling Memories. Time to ace the real test. Once the AI has built up this rich external bank of high-confidence thoughts, it is ready for the real world. During this recalling stage, when a brand new question arrives, Step 1 triggers the AI to quickly scan its external memory. It looks for a past scenario that is highly similar to the current problem. Then, in Step 2, the AI selects the most useful thought, the most analogous reasoning process, and uses it to quickly and accurately resolve the new prompt. It's literally leveraging its own past experience to solve a new, completely unseen problem.
Okay, Section 5, the results and impact. Let's look at the hard data.
So all of this sounds great in theory, but looking at the performance data, this framework really proves its worth. The researchers tested MoT across multiple reasoning benchmarks, comparing it directly against the standard approach, which is few-shot chain of thought prompting. And across the board, memory of thought consistently outperformed the standard. Take arithmetic reasoning, for example, a notoriously tricky area for language models. MoT drove a really notable 4.4% improvement, jumping from 49.7% up to 54.1%. We also see solid gains of 2.3% in common sense reasoning, 3.8% in natural language inference, and 2.8% in factual reasoning. The AI genuinely made itself smarter just by being allowed to remember its own good ideas.
And honestly, what you should really take away from this, especially if you're a developer or researcher, is that this transformative breakthrough isn't locked away behind some massive corporate paywall. The code has been entirely open sourced by the team at Fudan University. Anyone can go to GitHub right now, find the repository, and start experimenting with giving their own AI models an external memory.
Which leaves us with a truly fascinating question to ponder. If we can now build AI that continuously self-improves, literally learning from its own past experiences without expensive human guidance, what complex human tasks will it autonomously master next? The ceiling for AI capabilities just got significantly higher. Thank you so much for joining me for this explainer, and keep exploring.